Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing functions and identifying features. This is standard A.3C in the great state of Texas, and we are using item number 16 off the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the water level of a river measured each day during a 2-week period. And the graph models this linear relationship between, we've got the water level of the river in feet, right? So that's going to be our y-axis. And then the number of days the water level was measured, that is going to be our x-axis. All right, so it looks like the water level goes from 16 to about maybe 19, not quite 20, and it's measured for 14 days. That's what it looks like here. So what is the meaning of that y-intercept, right? So first we need to identify what is the y-intercept, and then we need to interpret what that actually means. So let's talk about our intercepts. So there are actually two intercepts in most graphs. So we've got the x-intercept and we've got the y-intercept. We're looking for the y-intercept, but let's just go ahead and define both, right? So the x-intercept is where the function crosses, since it's the x-axis, the x-intercept, it's going to cross the x-axis. All right, so then the y-intercept is going to be where the function, or the line, if you're looking at it like that, crosses the y-axis. So our x-intercept is going to have a y of 0. So we don't know what the x is, but it has a y of 0, because when you have a y of 0, right, that means you're going to be on that x-axis. And in our y-intercept, the x is 0, because you are right here on this y-axis with an x of 0. So where does it cross this y-axis right here? Well, it looks like it's crossing right there at 16. So we can really identify this two different ways. If we want to give the full coordinate pair, we would say, all right, our y-intercept is x of 0, y of 16. But in shorthand, we can also say, you know what, our y-intercept is just 16. Because if we say that, we also understand that the x value is 0. Since it's the y-intercept, that means it has to have an x of 0 in order to cross the y-axis. All right, so we've got a y-intercept of 16, because visually we can see that's right where it touches that line. We don't see an x-intercept. Now, if we wanted to, we could continue that, and eventually in the negatives, right, it would have an x-intercept of negative, pretty large number, but we just don't have that on our graph. We only have quadrant 1 here. So which statement best describes this y-intercept of 16? Well, let's look. The water level increased by 0.25 feet per day. Feet per day. That's y over x. You know what that is? That is your slope. So that's what that slope is, since the feet is the y and the days are the x. So it's probably correct. We haven't calculated it. That looks good. It's a very gradual slope, but that's not what we're looking for. The maximum water level is 19.5, but that's not the y-intercept. That's with an x of 14, so we don't want that one. The initial water level was 16 feet. Aha! So there we go. That would be a good y-intercept, and the water level was measured for 14 days. That's just our range right here. So that's our range, our domain. That's not what we're wanting. So our answer here is H.